but we have to undo that negative. So you have to actually multiply everything by -1, and that becomes y equals x minus 3.
Okay.
Same thing for the last one here. When you subtract x, you get that minus y equals minus x minus 3. You got to multiply everything by -1. Y equals x minus, or x plus 3. Now, which of these 4 equations, 1, 2, 3, 4, has a slope of 1?
C and D.
C and D. So A and B are out. And we want the one that goes through 0, 3. So is it C or D? I don't know if you can distinguish between them.
It's D, right?
It's D. Yep. Good. Okay. Now, obviously, it helps me kind of walking you through the problem, but seeing more and more of these like this should really enhance your your abilities to do well on this test. Just do a couple more. The graph of the linear function f is shown in the xy plane above. What is the slope of this line just looking at it?
1.
So if it was 1, it would be going up 1, right 1.
Oh, 1 point, or just 0.5, I mean.
So this time it's actually going down and then right. We haven't looked at too many graphs. That's why I asked you here. It's going down 2 and right 1. So the slope of this line is actually -2. So let's review. Slope is rise over run. That rise actually could mean either going up or down, but you're always going to the right. The run is always to the right. So you have to move from left to right. So the other way you can sort of decide is like, and you get some snow where you live. If you were to sled, would you go down? Would this be good to sled down? Yeah, because it's you go real fast. That's a negative slope if you can sled down it. If you had a line that goes up and to the right, for hiking, that's another situation. So the slope here is the rise, which in this case is down run of 1. Okay, so it's negative. So what is the perpendicular slope to this?
It should be 0.5, right?
1/2. Yeah, maybe that's what you were meaning.
Yeah, that was what I was.
Okay. Total. There's a gap there for me. All right, got it. So it says it's perpendicular and it goes to the point 1, 3. So here's 1, 3 on your graph. All right. That's the point that it goes through, 1, 3. And then the slope, if you're going up 1, right 2, and then up 1, right 2, you can see how these points are on that line there.
Okay, yeah.
And so now it wants the value of what's called g of 0 when x is 0. So they're really asking for, let me do it in a different color here. They're asking for this point right here, which looks like it's about 2.5. Okay, but you definitely got that perpendicular slope stuff down. Yeah. Let's see here. Let's do one more. Do another graph question. All right, so just looking at the graph on the left, can you determine the slope of the line? So you might pick like that point and then this one way up here. It's got to go perfectly through. And I know you're on a screen and all that, but try to give me what's the rise and what's the run?
So it should be rise would be 3 and run would be 6.
So I'm counting 5 for the run. 1,
sorry.
2, 3, 4, 5. Yeah. So the slope of this line is 3/5. The rise is 3, the run is 5. Okay. Now, the line that we're asking about, it says in the XY plane above, which is really to the left, line M is perpendicular to L. Okay. So this is line M. L is perpendicular. So L has a slope that's perpendicular to this. What would that be?
-5/3.
-5/3. So what I want you to do is decide which of these four answers has this slope in it.
You want me to do the math right now?
Yes, yes, please.
Equals -5x. Okay, so I got A.
You got A.
Yeah.
That is correct. Good. Okay. Ready to switch to a new topic?
Sure.
All right. Charissa ordered 3 cans of lemonade for every person at her party. She also ordered 1 pizza for every 4 people. If she ordered 6 pizzas, which of the following could be the number of cans of lemonade she ordered? Okay, so I want you to read it out loud now.
Charissa ordered 3 cans of lemonade for each person at her party. She also ordered 1 pizza for every 4 people. If she ordered 6 pizzas, which of the following could be the number of cans of lemonade she ordered?
Okay, so what I would do here is I would say, okay, 3 lemonades, and then use this colon symbol for 1 person or 1p, something like that. This is like a ratio. Have you seen this before? Okay, and then but you got to be careful here because they tend to reuse the letters. So maybe we would write that out: 1 people or 1 person. Now it's 1 pizza for every 4 people. So if she orders 6 pizzas, how
24
many?
people
There's 24 people.
times 3 would be 72.
Yes. So what about this question is difficult?
This one wasn't very bad. I could read this one and understand this one pretty good.
Okay. All right. Now, let's see if I can find another one. Yeah. So here's another one. Maybe because it's like a pizza party or something, you kind of get the, you know.
Yeah, it's too logical for me, I think. That one
But
was
the,
just like, oh yeah.
but this one's gonna be a little different. It's teaspoons and medication. It's actually the same type of question. So
Yeah, this one
um, go ahead and read it out loud for us, please.
A physician prescribes a treatment in which a patient takes 2 teaspoons of a medication every 6 hours for 5 days. According to the prescription, how many teaspoons of medication should the patient take in 24 hours?
Good. Now, well, I'm going to read it, and what I want you to do is write down the important information as we're reading it. So, a physician prescribes a treatment in which a patient takes 2 teaspoons of a medication every 6 hours. So, if it were me, I would write down something like 2 TSP, something like that.
Okay.
According to the prescription, how many teaspoons of the medication should the patient take in a 24-hour period? And then I would write the new number and then figure out the multiplier. So how do you go from 6 to 24? That should be the question you're asking yourself.
You'd have to multiply teaspoons by 4.
Yes. So what would the correct answer be?
40. D.
You're multiplying 2 times 4, right?
Oh, 8.
Yeah, I'm really curious how you came up with 40 because they knew that someone would do that, and I have no idea. Maybe you
Yeah.
did 2 times 5 times 4. I don't
Yeah.
know.
Got me on the days. Not gonna
Okay.
lie.
Okay. No, it's a really interesting thing. Okay. Let's do another one. All right. I want you just to read this to yourself and write down any information that you think is useful as you're reading it. Okay. Have you finished reading it?
Yes.
Okay. Is the 25 degrees Celsius, is that useful information?
Not really. No.
No, because it's the same temperature. So it's unnecessary. It's 1500 meters. And then the word per means division per second. How long do they want to know this for?
15 seconds.
So notice how the units cancel. Maybe you wrote this down, maybe starting to see that.
Yeah, and I just multiplied 1500 by 15.
Yes. Now the only two possible answers that could be are A and B.
Yeah,
Do you have,
D.
it's B. Yeah, I was going to say it show you a technique, but you got it. That probably is not a calculator problem. So just keep that in mind. Okay. Here's another one. This is kind of a units question also. Try this one here. Okay, an electric company charges Jerome $0.05 per kilowatt hour of energy he uses in his house. If Jerome was charged $36 by the electric company, how many kilowatt hours of energy did Jerome use? Okay, so
It's like,
have you ever looked at the electric bill at your house?
no, I've not.
You might ask your parents, like what this number is. In Arizona, it's about 11 cents per kilowatt hour. And a kilowatt hour is a lot of energy, by the way. Like it's like, I don't know, you don't use unless you're like running appliances all the time, you're not using that much energy. Like your light bulbs in watts, kilowatts is 1,000 times that. I know you got bulbs in your house, but our energy is actually pretty cheap here. Okay. So there's a couple of answers that are pretty unreasonable in this problem. One of the things that I would want you to remember here is like 20 times 5 is 100 and 20 times 0.05 is 1. And this next one is like 20 nickels is a dollar. Do you ever count coins?
Yeah, I do. Yeah, yeah.
Okay, so that's kind of a good exercise to have. Now, why am I doing all that? Because if he spent $36, he got at least 20 kilowatts because 20 kilowatts is is $1. I got that by taking 0.05 and multiplying it by 20. So these are definitely out. So which one is it? Is it 180 or 720? You're really not supposed to use a calculator. You're supposed to use the fact that there's 20 kilowatts in $1. So it's kind of
It's,
like a ratio again. How do you get to 36? Go ahead.
it's D, isn't it?
It is D, yeah. But it's from multiplying by 36 to get 720.
Yeah, it wouldn't even make sense if it was 180.
Right, right. And you have a meter on your home. Almost every home does, unless you're disconnected from the grid, which I doubt you are. It's kind of interesting to go outside and see like how slow it moves sometimes, or how fast it's moving, if you're using a lot of electricity. Guess we should work this out together. Okay, could you read this out loud for us?
The density of an object is equal to the mass of the object divided by the volume of the object. What
Pause.
is
Hang on. So I'm going to read that one more time, and I want you to try to write the equation. The density of an object is equal to the mass of the object divided by the volume of the object. So there's density, mass, and volume. Could you write the equation for those?
D equals M over V?
Exactly. Okay. Now, did you already know this?
Yeah, I did.
Okay, so what's one of the techniques we've talked about is going right to that last sentence. So if you already knew this, but they give it to you in case you don't. If you didn't already know this, and it just went right to the question, what is the volume in milliliters of an object with a mass of 24 grams, that's M, and a density of 3 grams per milliliter? Now this is the equation. You could solve it, but you're just trying to figure out what number goes down here such that when you take 24 and divide it by that number, you get 3. What would be the best choice for that?
8.
Yes. Very good. Okay, kind of a new question. So none of these questions aren't as connected as some of the other ones are. I'm trying to find a few more that I can give you to do, but they're just all kind of disconnected. All right, so the formula above gives the monthly cost C in dollars of operating a delivery truck when the driver works a total of X hours and when Y gallons of gasoline are used. If in a particular month it costs no more than $2,000 to operate the truck and at least 150 gallons of gas were used, what is the maximum number of hours the driver could have worked? Okay, so another technique is to just read the question again. They give you the formula: X is hours, Y is gallons, but we don't know. There's something missing here. Oh no, I'm sorry. X is the hours and Y is the gallons. Okay, sorry. I had to read it twice myself. So they're telling you that C is 2,000. What is the value of X or what is the value of Y? Which one do we know?
I know 4Y or Y is 150. And if I multiply that by 4, I get 500.
Try again.
Oh,
4 times 15 is 60, so it'd be 600.
oh, my fault.
Okay, so you got 2,000 equals 10X plus 600.
And I'd have to bring the 600 over.
Yes. Okay, so could you finish up solving that for us?
Yeah. 140 hours.
That sounds right. Okay. I do have one really similar to this that I'll have you try. So let me snip that in. And I'd like you to try working this one out on your own. It's not a calculator problem, but if you feel like you need to grab it, you're welcome to.
A spring is attached to the ceiling when an object M kilograms is attached to the other end. Spring stretches to of L centimeters. It's known equation above. What is M when 73? .5 bring over 4. .49 equals 3. Okay,
Do you have an answer? Do you want to tell me what you've done? What would help you here?
so I did 73 equals 24 plus 3.5 M.
Good.
And then I brought the 24 over and
Okay.
I
What did you get when you subtracted?
49
Okay.
equals 3.5. And that's like 16 or 15.
So the answer is probably 14.
So I just put that then.
Yeah, it does. It is actually 14, but like what I was hearing, and I think this is what you meant, is like it's not that, it's not that, it's probably not that
Yeah.
by estimating. Yeah, and you're supposed to do that.
Okay.
Good. So this is a good example of a problem where if you just went right to the last sentence, you didn't have to read any of this. Now, do you know that for every problem? No,
Yeah.
but that you will get a few problems like that. Okay, let's take a 1 to 2 minute break. I'll check back with you at 29 and we'll switch to a new topic.
All right.
Okay, let's get back to it here. So this is one of those really long questions that you might see. There's a lot of words here. Okay.
Yeah.
And I know this can be overwhelming. And I actually don't know what order this appeared in because it's a snip. But let's just so let's go. We'll actually start here with Rocco. Rocco is saving money to buy his first car. He works 15 hours each week and saves $10 for each hour he works. He's already saved 3,500 and plans to save at least 5,300. He knows there will be an 8.5% sales tax on the purchase price of the car and a title transfer fee of $15. He will use the formula below to determine his gas mileage Y in miles per gallon for the number of miles M the car can be driven using G gallons of gas. To Okay, so now Rocco will need to pay a total of 5,246.87 for the car, including the sales tax and transfer fee. How'd they come up with that? Okay, so they're telling you like this is the final price. That's what they're trying to tell you. So I want to help you kind of work through this. So that's the final price, but you need to back out the sales tax and the transfer fee. And this is definitely a calculator problem.
Okay.
Right. When you have you bought anything recently? Have you like looked at a receipt where they charge you sales tax?
Yeah.
So there's usually a line that says subtotal, then tax, and then total, something like that.
Yep.
Okay. So they're giving us the total. We know the tax is some amount. We got to calculate the subtotal. So to go from the subtotal to the total, you take the sales tax and you add it to 1. So 1.085 is your how you go from the subtotal to the total. So like for example, let's say it was $1,000 was your subtotal. If you multiplied by 1.085, that would give you your total, which would be 1,085. Do you have a calculator handy?
I do.
Okay. So now if you have that calculator, to go the other way, you divide by 1.085. So I want you to do that for me. 1,085 divided by 1.085.
I got 1,000. Yeah.
Perfect. So they're giving you the final price and they're giving you the sales tax. You need to take this final price and divide it by 1.085.
46.87 divided by 1. I got 4,835
4,835.
0.82 and
So
change.
roughly there.
Yeah.
Okay. Now, what we don't know, and this problem, that's why this problem probably isn't used, is we don't know whether the transfer fee has tax collected on it. And that's another issue. That's like a different class, whether it should or shouldn't, but you have to adjust that number by $15. You have to subtract that from it.
Okay. So it'd be 4,020 or
Roughly.
4,820
Yeah. Which means it's probably
B.
B. And all this other stuff really wasn't relevant to the question, but it was there for some reason. Maybe I needed it in another question. I don't really remember. So okay, I should have done this one first. That's it. The sales tax is really a nasty thing in our world. It's just, you know. Did your dad ever try to explain like you wanted to buy something and it was $10 and you get to the counter to pay and he's like, no, it's actually $10.81.
Yeah.
Like, but I only got $10. All right. Which of the following represents the result of increasing the quantity X by 9%? So it's essentially the same thing I just talked about. When you want to increase a quantity by a percentage, it's always 1 plus the percentage.
It'd be A.
It would be A. Yeah. Now, what B does, kind of interestingly, is it gives you the tax. Okay, so like let's say what does a basketball cost if you want to buy a nice one for indoor use or outdoor?
Probably $15.
Okay, so let's go $15. And I don't know, let's say sales tax in your state is 4.5% because you got a great state you live in. If you multiply this number by 0.05, could you do that for me? You got a calculator?
68 cents.
Yeah, 68, that's right. Okay. And then if you add these together, if you add the 15 to that, it's 15.68, but you could go directly there by multiplying 1.045. And if you don't believe me, go ahead and try it, and then you'll at least have one example of believing me. Yeah.
That's cool.
Yeah. Now, another kind of situation that I don't know if it'll come up here, but we should talk about our discounts because they are part of this test. So is there something that you've been wanting to buy for a while, or you're hoping, next birthday, mom and dad will come around and they'll gift you with something?
There's these really nice tank tops for basketball. Getting
Okay. What do any idea what they cost?
$85.
Okay, they're $85. Okay. And let's say the store owner sees you in the paper and he's like, oh, I want to give you guys a 20% discount. Okay, because they see your team's ranked. He's like, oh, that's great. I want to support the local community. If you multiply this number by 0.2, and I'd like you to do that.
17.
17. Do you have any idea what this number represents? And there's two answers. It's either what you pay or it's the discount. It's the discount. So what you actually pay is 85 minus 17, which is 68, or 80% off the original. So if you take 85 and multiply it by 0.8, which I'd like you to do, guess what you will get?
Oh, cool. 68.
Yeah, so the people that worked in sales a long time ago, they used to carry around calculators, and this was especially common in jewelry stores. So if you've ever been to a jewelry store, there's a lot of things, rings and earrings and diamonds and bracelets and watches and blah blah blah, right? And maybe someday you'll be there with someone and you'll want to buy them something, and the person will look at the price tag and they'll be like, oh, it's $168, but they say, well, right now we've got a 30% off sale, and you're like, great, because I don't have $168 right now. Well, here's what they don't do. They don't do this. They don't go up here and multiply by 0.3 and then subtract. If it's 30% off, they multiply by 70%. And that's what you've got to get in the habit of doing. If you see a discount, you immediately go 100 minus that, or 1 minus the decimal. So
Okay.
to get the new price, you're going to multiply this by 0.7, because you don't care what the discounted amount is. You care about what you're going to pay, not the discount.
So it'd be 117.6.
Yes, something like that. And that's a really important thing here to do. I'm not sure we've got any questions like that, but what you have to decide, and this is almost more practical than anything, is like, do you care about what the discounted amount is, or do you care about the what I pay amount is?
Yeah, I care about what I pay for.
Exactly. And that's why the sales are nice, but really, whenever you start seeing something 10% off, you want to think of it as, I'm paying 90% of that price. 20% off, I'm paying 80% of that price. Any questions on that, or any thoughts, opinions?
Nope.
Okay. Okay, so we're sort of in the same area, but this is it's just another, we're in the kind of like percents area of the course. But we're doing a lot of story paragraph questions, and I apologize, just the way it goes. So on the left, you've got a table, number of activities, percent of students. It's sometimes a good idea just to do a quick check that it adds up to 100. Because sometimes they ask you about the missing percentages, but this one works out nicely. 5 and 30, 35, 55, 90, 10 is 100. So the table above or left shows the distribution of the number of extracurricular activities that students at a middle school participate in. If the number of students who participate in 2 extracurricular activities is 120 more, not 120, it's 120 more, one word makes all the difference, than the number of students who participate in one extracurricular activity, what is the total number of students who attend the middle school? Okay, so maybe in your own words, and maybe we need to read this again, but if we know how many students do one activity, okay,
Okay.
then we can figure out that the ones that do two is 120 more than that. And any idea, like looking at these percentages, how are they kind of related? If you like roughly, if you were to estimate.
I have no idea.
Okay, 30 and 55. Like if you're a 30% free throw shooter versus a 55% free throw shooter, what does that mean?
55 is you make more shots. Sorry,
Yeah,
my mom walked in and I was focused on that. Sorry.
that's okay. Do you need to break away to
Nope,
deal
we're
with
good.
anything? Okay, all right.
She's good.
Yeah, and so it's okay to put stuff in terms of things you already know. So this one's a little wonky. We do have to go to the answer space to do this. Okay, so these numbers right down here, they're the total number of students who attend the school. Okay, and we're gonna pick 600. Okay, and if the total is 600, that means, like, for example, more than two would be 60 students. How did I come up with 60 students using 10% and 600?
I'm sorry, what?
Okay, are you okay? Because there's a lot in this problem to go through. Just want to make sure we shouldn't move
Yeah.
on to something else. Okay, I'm saying let's pick the answer C for the moment. If there are 600 students in the school and 10% of them do more than two activities, how many students do more than two activities? And I said it's 60. How did I come up with that?
You multiplied by 0.1.
Exactly. So let's just say this is the right answer. Tell me how many students are 30% and how many students are 55%.
180 in the 30%
And
and
you're
30,
and you're
330.
you're allowed to use a calculator for the next one.
Uh,
Did you use a
Sorry, what?
330 is what you said, right?
Yep.
Okay. What is the difference between these two numbers?
150.
And we want 120. So we know that's not the right answer.
It had to be smaller than.
So how do we make it smaller? Do you think we should go for a bigger number or a smaller number? Well, here's the answer. We're actually going to try A, and I'm pretty sure A is wrong, but you're going to see what A does here. This is called the AC approach, or it's sometimes referred to as BD when you have 5 choices. I believe the ACT gives you 5 choices. So we're going to try 240 now. So what is 30% of 240?
72.
Okay, and then do 55%, please.
132.
132. And what's the difference between those two?
50.
And that's too small. So when we did 600, it was too big. If we did 240, it's too small. So what is the correct answer?
B.
Yes. And
Oh,
it's
okay.
a way now you probably, and I probably would have, if I were doing this, and I think you would have too, you would have said, hey, let's just do 480. That looks pretty close. But by squeezing the answer, you're like, oh, too big, too small, too high, too low, if you get two extremes and you know it's in the middle, you've got it. Now, here's what you don't want to do. You don't want to check that it's B, because you already know it's A. A is wrong, C is wrong, it's squeezed in the middle. There we go. Okay, new question. Boyd grows only tomatoes and raspberries in his garden. Last year, he grew 140 pounds of tomatoes and 60 pounds of raspberries. This year, production by weight of tomatoes declined by 20%, and the production by weight of raspberries declined by 50%. So this is where I might make a table. So this is last year, and tomatoes and raspberries. And one of the things that would be really good to do is to not write out the full word, to use a single letter or a couple letters.
Just to
And
be
then,
quick.
yes, exactly. So he did 140 pounds of tomatoes and 60 pounds of raspberries. This year, tomatoes declined by what percent?
It declined by 60. So
20,
that
20,
multiplied by
20%. Well, so this is like the jewelry
oh
store.
shoot.
This is the jewelry store. Do you care how much it declined by, or do you care about how much he got? And the answer is we don't know yet, but you got to be careful there.
I was looking at the wrong number completely. Like I was looking at the 60 pounds.
Okay, so give me though
112.
how many pounds of tomatoes he has this year.
He had less than, so it'd be 112.
Yeah, 80% of that number, right, is 112. Is that what you did? Okay. And then
Yeah.
50% less is 30.
Yeah.
All right. So if it asked, like how many pounds, you got the answer. But that's not what's asking for. It says by what percentage did the total yield, and what does the word total yield or phrase total yield mean to you?
Like all of it together.
Yes. So last year, the total yield was 140 plus 60 or 200. This year, the total yield is 112 plus 30 or 142. Okay. So here's what you're trying to solve now. How did you go from, so K times 200 equals 142.
So I'm figuring out the percentage between the two. Like,
Yes. Yes. And you can do that by dividing both sides by 200, and you're going to get 0.71.
yep. So
Okay.
it'd be D.
Well, D is 70. This is the and that's why you gotta be careful here. This is how much was remaining, not how much it went down.
So it'd be A.
It'd be A, yeah.
Oh.
And there's just a couple of words in here where if it says, how much did the yield change, but here it says decline. It could have been 71, unless it says, like here we did in a previous problem. I go and find the language. It says to the nearest dollar. Okay, to the nearest dollar, and you said it was like 480, 4,835.60 or something. Unless it says you're rounding, do not be like, oh, 71, 70, that's it. Unless it tells you somewhere that you're rounding, do not round.
Okay.
All right. Let's see here. Let's see if we get some quick ones left. We may have already done this one, but there's some short ones here just to close out some percentages. Could you try this one for me, please?
C.
Yes. Okay, we got to go find something else. Okay, yeah, here this is like a classic. Oh boy. This is your classic test prep question. There you go. Could you read this out loud for us?
The expression 1.60W represents the results of increasing a quantity W by what percent? 60.
Okay, it's 60, yes. All right, 2.6 would be 160%, and it's very easy to mix those up. If you need to, you can try numbers, but that's probably your best approach. So, all right, you're still planning on taking the test sometime, not first week of October, is that right?
It got pushed back to the 18th because the facility they had wasn't able to do it, I guess, because they have like a VBS thing.
Okay. Well, we've probably gone through about half the material, so you're gonna, see some increase. So I guess we'll just keep working on it. Talk to your dad. We've got one more week for sure. Um, but yeah, if there's anything you ever want us to work on, please just let me know. I would probably, hopefully, you'll start getting into some math stuff in your other class too, just to help with.
Yeah, I think that's next week.
Great. All right. Well, have a great weekend, and we'll get going again next week on Tuesday.
Thank you so much.
You're welcome. Have a great night. Bye now.
Goodbye.